Hello everyone, welcome to day 20. I am continuing with the pattern problems and today I'll be doing the prefix sum problems. So we'll start with the first one. The first question is find the middle index in the array. Given a zero indexed integer array, now is find the leftmost middle index that is the smallest amongst all the possible ones. A middle index is an index where this is equals to index plus okay, if the middle index is 0, the left side sum is considered to be 0. Similarly, if the middle index is this, the right side sum is considered to be 0. These are the kind of questions which makes you question your English rather than coding skills. Return the leftmost middle index. That I didn't get it. Let me see the example. So in this they are saying this is the middle index because the sum of numbers before 3 is okay. So okay, we need to return index where the sum of all the numbers before it should be equal to sum of all the numbers after it. Similarly, in this one, if this is the middle index, the sum of all the numbers before it is 0 and after it is also 0, and in this it is not possible. Got it? So we are returning -1. Okay, so the brute force approach for doing this would be that we iterate over this array and we consider each as a middle index and see if that is correct. So first of all, we'll check if 2 is the middle index. For that, we will check the sum of all the integers before it, which is 0, and then we find the sum of all the numbers after it and then equate it. Similarly, if it is not equal, then we will see that if this is the middle index, then again we'll do the sum on left side and right side and again compare and so on. So in this case, in brute force approach, we are iterating over this array which will take n time complexity, whereas adding all the numbers also takes n, so this is n square time complexity. That is the brute force approach. Now one other thing we can do is that what if we take sum of all the numbers initially. So let's say currently this is the array and we take sum of all the numbers. So it is 8 plus 4 is 12, plus 2 is 14, plus 3 is 17, minus 1 is 16. So initially the sum is 16, right? Now we will start iterating over this array and we can subtract the numbers to see if we are getting a result at some point. So let's say we'll take two variables. One is pre-sum. Okay, pre-sum is initially 0, and let's call this post-sum. Post-sum, okay, is 16. So all the numbers equals to 16. So initially, once we start from we consider that this is the middle index. So we need to subtract it from post sum because this is not included in either of the sides. So post sum will become 14 and pre sum is 0. So it is not the result. It is not the answer. 2 is not the answer. So we'll move to the next one. But before that, we'll update post sum as 14 minus 3, which will be 11, whereas pre-sum will become pre-sum plus this number. So pre-sum will become 3. Now again these are not equal, so it is not the result. Now again post-sum will become, now we are checking for -1. So 11 minus -1 is 12. Whereas pre-sum is 4, right? 3 minus, oh sorry, we need to add it, right? So 3 minus 1 is 2. This is again not equal, so we'll move forward. Post-sum will become, post-sum is now 12 minus 8. So it is 4. Whereas pre-sum will become 2 minus 8. right? So it is -4. That means I'm doing something wrong, because that means I'm doing something wrong because these should be equal. One second, let me do it again. Post sum is initially 16. Why? Because 8, 12 minus 1, 11, 12, 13, 14, 15, 16. This is correct. And pre-sum is 0. Now in this case, what we are doing is, initially we are doing post sum. Post sum mein we are subtracting 2. So in this side we are subtracting, in this side we are adding. So in this we are subtracting 2 16 mein, so it becomes 14. Whereas pre-sum mein, whereas pre-sum will remain same. In this step we will not do anything. In next step we will subtract. So we need to subtract it. Okay, this is wrong. This, we have done something wrong here. I skipped 2 somehow. One second, let me think again. So initially let's take I. Okay, when I equals to 0, that means our array value is 2. Now we need to add all the numbers on this side, which is pre-sum, whereas we need to add all the numbers of this side, which is post sum minus 2. So it is 14 and 0. This is correct. Now next is I equals to 1, which is 3. So in this case we need to subtract 3 from post sum, so it will become 11. Whereas we need to add 2 to pre-sum. We need to add 2 to pre-sum, right? So pre-sum will become 2. So we also need to keep track of this pre-sum plus previous value. Then I equals to 2, which is -1. So post sum will become 12, because 11 minus -1, post sum will become 12, and pre-sum will become 2 plus 3, which is 5. Pre-sum will become 5. Then I is 3, which is 8. Post sum will become 4, and pre-sum will become 5 minus 1. Basically 5 plus -1, so 4. So pre-sum is also 4, and that is why this is the result. Now I'm doing it correctly. So basically we don't need to add it in the add this in the current, rather we need to add the previous value. So this also we need to keep track of. So let's say let's go ahead. So initially I'll take 2 variables, int post sum, which will be sum of all the numbers. I'll calculate it in a bit, and int pre-sum will be 0. And we also need one more variable, which could be current. Okay, current. Initially this is also 0. Now for int I equals to 0, I is less than n, I plus plus, I is less than nums dot length, I plus plus. Now in this case first of all we need to remove this number from post sum. So we can update current is, or maybe later we can check, we can update post sum equals to post sum minus this value, so nums I. Okay, and then we need current sum, pre-sum will remain same, so we need to check if pre-sum is equals to post sum, that means this is the result, so return I. Otherwise for the next iteration we will update pre-sum as pre-sum plus current, because initially we don't need to add anything. Pre-sum is 0, so current will be 0, but from next iterations current will be this particular index. So current will be num psi, and if somehow we are not able to return anything, that means there is no result for it, so I'll return -1. Okay, and one more thing, we need to calculate post sum. So I'll write it as first initially 0. Wait, and for int I equals to 0, I is less than nums dot length I plus plus post sum plus equals to num psi. Perfect. Let me just remove it. I'll run the code. Sorry, in case it was supposed to return -1, it is returning 1, and in other cases returning -1. What I've done, 1 second. So post sum is initially 0. Oh, we are up, no, this is fine, current is fine. Then int I equals to 0, post sum equals to post sum minus num psi. If pre-sum equals to post sum, return I. Pre-sum equals to pre-sum plus current equals to num psi. This is fine only. Let me try to print the values and see. System dot out dot println pre-sum plus post sum. I think we should be comparing it. 1 second. So post sum initially is post sum should be, let me get my example back which I had written earlier. This thing. So here what we're doing is post sum is initially the whole thing minus current value, that is fine, and pre-sum initially is 0, that is also fine. In next iteration, and current will become num psi, current will become 2. Now in next iteration, oh, I get it, this needs to be done after this line. That was right. Let me try to run it once. This is fine now. Done. this case the time complexity is order of n, space is order of 1. That's all. I'll quickly do one more question. Product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any specific prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algo that runs in order of n time without using division operation. Okay, so they are saying that if this is the array, then we need to return an array such that at each index we need a product of all the numbers except that particular number. So here first index will be multiplication of all of these. Second index will be multiplication of all of them except 2. So 4 3 12 12 1 1. ठीक है, समझ गई. Okay, so let's go step by step. First of all, brute force approach for this would be for each index, as they are saying that we can't use division operation, then for each index, let's suppose for this index we'll go through all the numbers and multiply them. Now again for this index we'll go through all the numbers and multiply them except this. Similarly for this we'll do the same, and this will take n square time complexity, right? Because one time we are iterating, second time we are again iterating and finding the product of all the numbers. This will take n square. The other way of doing this is using the division operation. What we can do is we multiply all the numbers and get a result. So let's say multiplication of all of them is 24, and then at each index we'll just divide it. So 24 by 1 is 24, 24 by 2 is 12, 24 by 3 is 8, and 24 by 4 is 6. This will be the result, but this is using the division operation, right? Now we can't use the division operation, as well as we need it in order of n. So for that, similar to the previous question, what we can do is for each index we can find the multiplication of left side and multiplication of right side. So let's say for 3 we need the multiplication of all the numbers on the left and all the numbers on the right and multiply them. And for that we can store the numbers. So let's say we create two arrays. First array will contain multiplication on all the left side numbers. So for 1, multiplication of all the left side is 1. For 2, multiplication of all the left side numbers is 1. For 3, it is 2 and 2. For 4, it is 3 to just 6. Similarly, we'll take one more array and keep the multiplication of all the numbers from the right side. So for 1, it will be, we can start from the end to calculate. So for 4, it will be minus 1. It will be 1, because we are considering that the last index after this, it will be 1. If we consider 0, then it will become 0. 1 is fine. And then for 3, it will be 4. For 2, it will be 12. And for 1, it will be 24. Okay, so these are all the prefix numbers. This is pre-multiplication, this is post-multiplication. And now what we need for each index, for the output, we need the multiplication of these two, because these are multiplication of all the numbers on the left except that number, and this is multiplication of all the numbers at the right except that number. So if we multiply, we'll get the result. So 24 into 1, 24, 12 into 1, 12, 4 into 2, 8, 6 into 1 is 6, and this is the result. I think this is a good solution for this. but they are saying, can you solve the problem in order of one extra space complexity? The output array does not count as extra space for space complexity analysis. Okay, so basically we can't use extra spaces, but the output array could be a extra space. So basically we can use one array. So what we can do is we calculate the pre multiplication for that in the array, and also we can keep track of post multiplication in a variable. So post multiplication in a variable, initially it will be 1. Now for this, and we can update the same array with the result, because we need to multiply it only. So let's say post multiplication is 1. Now for 4 we need this is pre multiplication, right? So this is this pre multiplication? This is pre multiplication. Okay, so post multiplication for 4 we don't need to consider the 4, but and we also take a current, so current is also 1. Now first of all, for 4 post multiplication is 1, so we will multiply it by 4. So it will become 1 1 2, and 6 into 1 is 6, and will update current with the current value. So current will become 4. Or we don't need to take it, we can just update post multiply it with the current value. So 4. Now next, in the next index we just need to multiply, for the next index we just need to multiply this by post. So 4 2 8 and 6, and then multiply 4 with the current value. So 4 3 12. Now in the next index again we'll do the same, 1 1 12 8 and 6, and for the next one we can multiply it with 12 with 2. So this will become 24, and for the next index it will be multiplied by 24. So 24 12 8 6. I think this is doable. So what we are doing is, basically initially what we did, we'll do the same. We will calculate the pre multiplication for each index. So for 1 it will be 1 by default, for 2 it will be 1 because because of this, for 3 it will be 2 into 1, so 2, and for 4 it will be 3 into 2 into 1, which is 6. So this is pre multiplication. Now for post multiplication we are just keeping track of one variable, and we can update the post multiplication itself in the same array. So for 6 it will be multiplied by 1 because initially this is 1, and we'll multiply with the remaining value and so on. So this at last we'll get this. I'll write the code. So initially will be 1 int, and we'll take int array let's take this as a result because we are returning this also. Result equals to new int of size nums dot length. Now to calculate result, 0 will be 1, for int I equals to 0, I is less than nums dot length I plus plus. Let's take it from 1. So result I equals to result one sec. So result I will be nums I minus 1 into result I minus 1, right? So basically this value will be this is 1 by default, this value will be this value into this value, then this will be this value into this value, then this will be this value into 3. Okay, this is fine. And then post multiplication will be 1, and then again we'll write the for loop, but we will start from the last index. The nums dot length and greater than equals to 0, I minus minus, and at each index we need to multiply this value with post multiply. So result I equals to result I multiplied by post multiple, and post multiple will get updated with post multiple will get updated post multiple into current value, so nums I, and return result. Let me try to run this. -1, sorry, last index is is it possible that there is only one element? 2 is okay, it is not possible. Fine. What if there are only 2 elements? Let me check one more case just to see if it is working. This is also done. I'll check the solutions quickly. Okay, there is a DP solution for it as well. We can easily understand all the approaches by seeing the code, which is easy to understand. Time complexity code n square space, and this is the brute force approach. Then they are doing the same thing with 2 arrays. This is DP, it is the same solution. See some more cases. I think it's the same thing they are doing. Okay, I'll close it. I'm just checking the next question. We'll do it tomorrow. Maximum product subarray. Given an integer nums, find the subarray that has the largest product and return the product. The test cases are generated so that answer will fit. Okay, now note that the product of an array with single element is the value of that element. 2 3 2 3. In this it is 0. Maximum in positive side they are asking now. Okay, I'll do this question tomorrow.